Whenever you deal with a network, you always focus on several physical components, and in every Cisco-driven network, we're always going to have these components making their presence known. Of course, the endpoints, that is the personal computers which are attached to the networks, will have what's called a network interface card or a NIC. These intelligence devices actually take information from the personal computer and translate it into a format that can be understood by the network by using a variety of techniques and protocols and so on. The network interface card is normally connected directly to some sort of network media, such as Ethernet. One of the components that you will find on every Ethernet cable is some sort of a connector. In this case, we have an example of an RJ45 connector, which is used for unshielded twisted pair, or UTP, Ethernet connections. This connector will plug right into your network interface card and then right into the next device over this cable, which is the switch. Switches are typically devices that provide connections to the network. They concentrate a large collection of devices into one single unit. A switch can actually have anywhere from 12 ports all the way up to 800 or more ports, giving us a very high density of connectivity for our network. Moreover, switches come in quite a few different flavors to lend themselves more functionality to the network environment. In most cases, we also have routers in local area networks. A router's job is to provide interconnectivity between separate segments on the network, which are also known as physical subnets. Routers also move the data or route the data from one segment to another. Now, the internet is actually made up of an entire collection of routers, which know how to move the data from your computer to the destination computer on the internet. The beauty of this is that we have a device that has the ability to actually move data around intelligently, always using the proper or best path to get data from point A to point B. When we look at the common physical components of a network, in most cases, whether it is a small home office or a big corporate office, we will find almost the same technology being utilized. A network exists because there is a compelling reason behind it. Primarily, it's the benefits of being able to share the various resources that are required on the network. For example, centrally located printers have to be shared by many different users in the same office. We must be able to access centralized storage on the network where we possibly have terabytes of data that everybody uses to run their business, their database, and so forth. We may possibly have an IP telephony environment where instead of using a standard telephone, we use something like a Cisco IP phone using Cisco Call Manager to facilitate IP telephony or Cisco IP telephony within our network environment. The data and the applications, the resources, and the backup devices we use are the compelling reasons to have a network. The more resources that an organization has to share, the larger and more complex a network becomes. Our main objective is to understand what makes up the network and why we need to have different components and different elements of the network to get a high-performing environment that satisfies the needs of the business. When we look at some of the major critical factors from the user's perspective, we focus on network user applications. Network user applications are very important for the existence of both our personal environments and our business environments. One of the most critical applications that everybody uses is electronic mail or email. This application is used almost everywhere networks exist, and that includes even yourself connected directly to the internet with no network. Typically, you will have an email account that allows you to exchange email with the rest of the world. Even if you exist in the largest of businesses where literally thousands and thousands of users share the same email environment, electronic mail has become the most mission-critical application for most businesses today. This application allows full collaborative capabilities between organizations, between people in the same organization, and between different applications that exist on the network, such as database applications or storage area networks, or being able to take advantage of internet-based content. Speaking of internet-based content, how do you get to the internet? Well, typically you use a web browser like Internet Explorer or Netscape Navigator, or even possibly Firefox, which is one of the newest web browser applications on the scene. It's done a fantastic job at creating a web browser or internet surfing environment that makes it possible for us to gain access to the millions and millions of web pages, libraries, dictionaries, and online books that exist on our information superhighway known as the Internet. The web browser is your interface to all of these resources. Another user application that uses the network is instant messaging. Though instant messaging was predominantly used in the user environment, where you would chat with your friends or family, it is becoming more and more a business-type application, especially in environments where we need to have real-time communication or non-voice communication, but real-time data communication between different members in the same department. And a really good example of this is a software development company that develops software and must constantly stay abreast of any changes that are being made by the various developers in their environment. Using instant messaging, they can quickly tell all of the other developers that are working on the same project something that they may be doing or may be querying another developer for ideas or something like this. Instant messaging is becoming more and more a business solution. We have to remember, though, that anytime you deal with user applications on the network, we have to focus on security and understand that all of these applications can be compromised. And of course, we do have to worry about making sure that they are as secure as possible on the network. So we never arbitrarily implement network user applications. But ultimately, one of our goals is to make sure that we have got the ability for collaboration in our business systems. What this means is that regardless of what applications we're using, we have the ability to collaborate. A lot of applications that have been built around groupware, for instance, will utilize collaboration to allow different departments or different areas of the organization to be able to collaborate on the same projects or the same data and be able to use emails, an interface which is really fantastic. In addition, a big part of most of our businesses involves database access. The ability for us to centrally store major amounts of corporate data into a unit that can be accessed by everybody and can be understood by everybody to run the business. Large percentages, 70 to 80% of businesses, actually rely on their databases, the most critical applications they have. If they lose their databases, they lose all their data, which is serious trouble. So database access is probably one of the most important applications for the business side. Each of these network user applications, from email to a large database server implementation, are all accessed based upon the same types of network components. The PC, the server, the network interface card, the different media types, the switches and the routers, they're all there. They all make it possible for us to have networks of any size that access these applications. Another important networking concept is network administration. Network administration is typically done by an individual who is responsible for actually taking care of the network, more or less like the doctor who's in charge of the patients and actually makes the rounds every day to make sure that all the patients are doing all right. Network administration applications will allow you to monitor the different activities that are going on in the network. For example, protocol analyzers will allow you to capture and view the packets that are being sent on the network. Part of our introduction was the fact that you broke out your packet sniffer, which is very much the same as a protocol analyzer, and you started to examine the packets that were coming inbound on the internet. That's exactly what protocol analyzers and packet sniffers allow you to do. They allow you to literally capture, encode, decode, and determine what's taking place on your network on a packet-by-packet basis. Some of the sample products that we have in Microsoft Windows include the Performance Monitor, which is a full-blown analysis tool that not only analyzes protocols, but also services and system-level information, as well as the Microsoft System Monitor, which is much more closely resembling that of a pure protocol analyzer. We also have what is known as Etherreel, which is a free download packet sniffer that does analysis of data packets. And we're going to use it in this series to examine some things that may happen on the network that we need to be familiar with. We also have the network sniffer itself, which is one of the originals. This provides full protocol analysis and packet sniffing capabilities for network managers that must be able to examine things in real time, as they exist on the network. In addition, we have other network management applications which allow us to do things like inventory or software metering or remote control of a computer to help with possible help desk problems. Being able to send problem notifications to all of our users about issues on the network, things like this, or even getting real-time information sent back to us, not by a user, but by the computer itself when something significant or something critical happens on that personal computer. Applications such as Microsoft's Systems Management Server, or SMS, the IBM Tivoli Enterprise, and Hewlett-Packard OpenView are a few good examples of these types of network management applications. And of course, they've been around for a very long time now. The industry has put a great amount of trust in applications such as these to give us the information that we need to be able to successfully manage our networks regardless of size. So these are the types of applications that you may be looking at when you're coming in from the network management side. And remember, there's always a very distinct difference between the individual that manages the network and the individual that simply uses the network. The individuals who simply use the network are more focused on whether the network is working fine as they access their applications, whereas the network manager is more focused on how well the network is working for all of the users to achieve optimum speed and reliability. Speaking of speed and reliability, these are some of the most important characteristics of a network. What does it mean when we talk about speed? What is the speed of a network? Well, speed is actually a measurement of how fast the data itself can be transmitted. You need to determine the speed of the network. Is it 10 megabit, 100 megabit, gigabit, or 10 gigabit? We've got capabilities of using speeds of 10 gigabits on a single line with 100 gigabit coming in a very, very short time. In fact, we have devices that are capable of 92 terabits per second, which is an amazing feat. But the limiting factor is the cost of these devices. It's the cost of these solutions, the components, the installations, and the people who are going to maintain it. Cost is always a limiting factor when we're trying to achieve maximum speed. So obviously there has to be a balance between speed and cost. You want to make sure that the speed of your network is going to properly encompass what's necessary for your specific data applications. But at the same time, we want to make sure that we can justify the cost of this solution. Would I like to have 10 gigabit Ethernet everywhere throughout the world? Well, definitely. Can I afford it? Not a chance. Not yet, at least. We will see that in the long run. Costs come down as the speeds continue to increase. Another major factor that you must be concerned with at all stages of networking, regardless of whether it's entry-level or very advanced, is security. You have to think about security. The security of the network itself is imperative, especially today when we see a variety of attacks that are happening and the intelligence of the attackers themselves, how much easier it's becoming for them to actually compromise our networks. We always have to ensure that we have achieved the appropriate level of security anytime we take actions that affect the network. Now, if your definition of security is impenetrable security, then that security is a fallacy. There is no such thing as impenetrable security. Ultimately, the objective of security has always been to have a unified policy that everybody understands and to make sure that you've achieved the appropriate level of security to either exceed the capabilities or the motivation of the primary attackers against your network. Security is like a locked door. It's a locked room. Are we safe just because it has a lock on it? Well, not necessarily. Somebody can find a way to get into that locked door, and they may, if they really want to. Security is about lowering the risk of that door being breached. The more complex your network becomes, the more complex your security solution becomes as well. From this information, you're beginning to see that a network is a collection of devices that communicate with each other across a shared medium. This allows us to communicate when it comes to word processing and spreadsheets and all of the other applications that we utilize on our local computers and across the network. This is the basics of networking, and this is where it all begins.